Next, we're going to have Jim Titt with Bolt Products. He's going to give a little background on Europe and the standards they have over there, and then be able to answer any questions. So come on up, Jim. Big round of applause for Jim.
Do I need the microphone or can you hear me?
Mike.
All right, microphone. Oh, I can hear you. Is this better? Can you hear me now? Okay. Well, it's interesting here. The weather's better and the beer's worse than Munich. So there you go. Right. It's briefly touched on that the climbers will, in the future, probably have some sort of standards either imposed upon them, or they'll have to find their own standards. You know, it's not really going to be possible to avoid it, I don't think, even in the United States, where liberties or perhaps plays a bigger, I would say, role than in Europe. And the European standards weren't in fact imposed on climbers, they were created by climbers. We need standards in climbing equipment, and I know it's the anarchistic younger climbers saying, no, it's an overbearing state imposing something on us. But they're the same guys that complain when they get 4 shots in their ropes after 3 falls. So we have rope standards, which they like, but when somebody says, well, we can have a bolt standard, oh no, it's really not allowed. And it's illogical. Because everything we do in our lives has standards. We all drive on the same side of the road, except from where I come in England, where we drive on the other side. But at least we all do it the same way, because otherwise it's just chaos. Okay? Sorry, I have to put glasses on. So why are standards a good idea? They tell us what the experience has been over the years before with bolts. People tried, like in the States, with 1/4 inches, and we know now that they really don't work for sport climbing. And we don't need to discover this for ourselves by falling off and crashing. We can actually look at somebody else's experience. He hit the ground because the bolt was too weak. And so when you add all this together, years and years of experience, then you can filter out what's good and end up with a standard which actually functions instead of a standard which is just theoretically based. And most of the European standards, the UAA standards as well, they aren't theoretically based. They are based, they come from a sort of 3-point system. One is experience, another is a theoretical basis, and the third is what's accepted, or what's acceptable. Because we could all have stronger climbing ropes, but nobody's going to go out with 16mm ropes and have fun, okay? And bolts are the same. They're actually a little bit easier than ropes because there's not a huge problem in using a slightly stronger bolt. It's not, drastically difficult. So when we try and create a standard, we look at what is it going to do? What is the good of the standard? Because mandatory standards, which the bolt standard in Europe effectively is, are actually good for industrialized countries as well. As a generalization, the European Union and presumably the American government are well aware that if you have a standardized system in industry, it's good for your economy. And bolts and climbing equipment are just a little part of that. But all the countries that have a poor standard system fail economically. And a strong standard system helps the industry. Okay? So the European standard appears from the European government. And it's a very complicated... Europe isn't actually federal, as the United States is, yet. They're trying to push us to this, but there's a lot of resistance. And it is actually a collection of 27 different countries. And all of these countries have their own legal system, and they have their own standard system. So So there's the British Standards Institute, there's the German, the Deutsche Industry Norm Institute, and so on. But in Europe, we have free travel of trade and so on. So if I'm living in Belgium, for instance, I can go work in Holland. Just drive there, go work. But the Dutch wouldn't like me if I was a Belgian and I came over with a cheap system to work. Whereas the Dutch guys have to use another system because they have all systems. So these standards are unified throughout Europe. And they're unified by the European Parliament. They send out a directive, it's technically called a directive. And they decide this is what is going to be the system in a country, in all of the countries. This directive directs each country to make a law incorporating the requirements, whatever they're looking for. You know, there are a lot of these directives. It's complex. It's like a central government that hasn't got its own power. They have to move this power into each country because each country has its own legal system as well. So what happens is, or with climbing equipment, the European Union made a directive regarding protective equipment, personal protective equipment. It's an enormous standard. It covers, you know, from your safety shoes to construction worker helmets to every single thing that you can carry and you wear that protects you. As part of this directive, they had to cover working at heights, we call it, but it's protection from falls from heights. So from construction workers, scaffolding, so on. Even right down to how high the steps are, you know, in a household or something. You know, the little ladders you use, all this stuff. And of course, climbing, while protecting you from falling from heights, is pretty important. So it got put into the legislation. It was a bit controversial because half of the, or a lot of the people in the climbing industry are doing it for a job. And so they technically come under exactly the same rules as rope access workers. And this was unworkable, you know, you can't put up two safety lines, you know, the instructor has to put up two safety lines, his fall arrest system, the whole lot. So they made an exemption for sport and said, okay, climbers can do it as they have done it. But they introduced, naturally enough, a standardized system for equipment. And these standards, there are a whole set of them covering ropes, carabiners, and all this stuff. Boats themselves aren't personal protection equipment because you don't carry them. They are a fixed piece of equipment. And by a sort of legal sort of fudging, they actually put this in, that boats are in this directive, but not covered by the CE Norman system. This is where it gets really complicated and a bit funny. Anyway, since you are all involved because you all have your CE stamps on all your climbing equipment, you have to know that these directives, they say the climbing equipment, whatever it is, say a rope, must conform to a European standard, carabiner and. These European standards are voluntary. And this is where it gets very confusing because the European standard system is run by an organization called CNORM, which is the direct equivalent of the American Standards Institute. And it's an industry, in fact owned by industry, an industrial norm system. And they write these norms. And they're completely voluntary. So for me, as a boat manufacturer, I can make anything I like, as long as I don't sell it in Europe. So I can make a non-standardized boat and sell it in America, but in Europe, I must conform to this European standard. It's just, that's how they refer it. In the directive, they will either refer to a European standard, they take even Japanese standards or American standards sometimes if it's suitable. I know for firearms, there are very few European standards, and so they actually specify that they must conform to American standards on dimensions and stuff. It's the way it is. So we have to make our bolts to the European standard, but we don't get the CE stamp. And this is where it really is a bit more confusing, but such is life. The CE symbol on your carabiner means it conforms to the relevant directive. And beside it, there will be a little EN and a number, and that's the standard it conforms to. But the CE is just it's like a seal of approval, and without the CE stamp, you cannot sell climbing equipment. But you can sell bolts, you can sell belay plates, ice axes, there are hammers, there's a few other things, which they don't quite conform to the requirements of the directive. And belay plates are the most notable that you buy. There is no CE stamp and no European standard for a belay plate, because the European standards are purely engineering standards. They are not physical performance standards, and a belay plate doesn't work if you don't hold the rod. So the function of the device is purely to do with holding the rod. So you can use anything as a belay plate. They have tried to make a European standard, and it has been pointed out, you just got to wrap the rope around a tree, and it's a perfectly good belay plate, or even around, a dead climber or something. So belay plate, they still are trying to put a standard in, but they really don't know how to do it. There is a draft standard out there for belay plates. We're drifting off bolts here. There is a draft standard for belay plates, which has been rejected about 5 times, I think. And it has nothing to do with how good they are at stopping you, which is what everyone says, well, this is rubbish. It's all to do with how strong they are, and they have no sharp edges, but it doesn't actually say whether it ever stop you hitting the ground. And the climbers quite rightly just say this is madness. Belay plate, we want to know, is it good or is it crap? Bolts are a bit they're easy. The standard is quite low, because engineering-wise, it's quite easy to make a bolt that strong. In fact, it's very difficult to make one that weak. The standard is 25 kilonewtons downwards and 15 outwards. And the piece of metal, they would be really thin. Climbers really wouldn't trust. We have actually tried to make a glue-in bolt that's only just achieves the standard. And it's only 3.5 millimeter stainless steel wire. It's a bit frightening. No climber would ever use one. You just go, geez, I just wouldn't use it, And the need to get a good surface area in the rock is the important part. If you're using bolt hangers and stuff, the hangers themselves are the weak point, always on the bolt, or at least in the European ones. And we certainly have had some hangers on the market which have been marginal or less than marginal. There's a famous case, it's still going on. In one manufacturer, the design was okay, it's just the material they used was sourced from China. And they turn out they only hold about 1/3 of what they should do. They break at about 5 or 6 kilonewtons, which really, even for climbers, Jesus, this is a little bit low, They do actually break in falls. They've been pulled from the market, okay, but someone had to find them in the first place. And luckily, they were actually found before anyone got hurt, because this peculiar European standard system. We make our gear, and we make it conforming to this EN 959. It's the standard we use. And we make our gear to conform to it, and then we put it on the market. But there isn't any independent testing of the equipment afterwards. It's all tested beforehand. And it is a criticism of the UIAA that they like writing their standards, but they never set up any system for testing the stuff. It's pushed over to the manufacturer or the user, but there's nobody actually sort of like policing it in any way. And especially for the boats, none at all, no policing whatsoever. But the reality is what happens is the manufacturers themselves, it's in our interests that all boats are good, no matter who makes them. We're not interested in getting a bad name, because otherwise we would get more pressure from the government to have better quality control or more stringent checks and stuff, which is only going to cost money. So what happens is the manufacturers themselves buy on the open market other companies' products and they test them. And when we see that there's rubbish, we sneak off. We either tell the manufacturer themselves, hey, you know, we've tested them and they're no good. And in fact, in this particular case, it's an Italian company, their products, they didn't like this. And so we went to the German Alpine Club, who are very, very powerful. They have a lot of money. They have got full-time lawyers work for them, and they have a legal staff. And they put the pressure on the manufacturer. They tell the manufacturer, if you don't withdraw them, we'll take you to court. Because the enforcement of these European standards is done by your local, I don't know what you have in the States, like trading standards officers, your consumer rights department of the government. I have really no idea what happens here. But in Europe, you have a minister of consumer rights, or they're the guys that make sure when you buy a gallon of gas, you get a gallon. There's all the same sort of group. And when you have a complaint over a piece of equipment, you go to them. They go and get it tested in the laboratory. If it's no good, they warn the company, then they fine them. The fines aren't really big, they're fairly big. You know, I think it's €5,000 for the $5,000 for the first offence, plus all the equipment's destroyed, which you lose your products. The end result is that we make boats. Nobody, especially in the boating world, is pushing to a limit. In, say, like carabiners and stuff, there's enormous pressure to make the gear lighter and lighter and nicer to use. And I'm involved with one of the carabiner manufacturers. 3 or 4 of the major European manufacturers don't, in fact, accept the European standard at all. They refuse to make them that weak. They just, like DMM, for example, the open gate is seen, open gate strength of carabiner is seen as too low. And so they insist it must be higher. For us, the boat manufacturers, I can't remember a boat that's ever got anywhere near the actual European standard in strength. They're all much, much stronger. The problem comes is putting them in the rock. The strength of the piece of metal is the easy bit. Any fool can do that, you know? Well, I can do it mentally even, to work out how strong it is. But to get the things to stay in the rock is the big problem. And this is where the European standard has been slightly changed and has advanced things with the minimum depths. It's, I don't know to translate it, but it's 70 millimeters minimum embedment. But of course, this doesn't work in some kinds of rock. The testing is done in a standardized concrete block, which is a fairly weak concrete block, admittedly. And so you have to modify what you're using to fit the rock. As was mentioned before, it's not a one-size-fits-all solution. Theoretically, to the European standard, it is. It's just 70 centimeters long, that's it. But that doesn't work in sandstone, ever. You know, there are a few other sort of rocks that it doesn't work in very well either. And it's something that even the manufacturers, we're even, well, not flexible, but developers, manufacturers, we're not going to force somebody to say, in rock hard ground, you've got to use this huge big boat, because a boat that conforms in this weak concrete, it's just not, it's just pointless. Right? We're flexible as well. We have to be. But we're mostly flexible on the longer, making it deeper. We're not too keen on making it weaker, because we actually go climbing as well. And yeah, there are pressures from developers, you know, it's time, the weight, the effort of drilling the holes, all these things, and their own, how much money they've got. Puts pressure on developers to cut corners or not do such a good job. And you really got to worry about the long term, as was also mentioned, the long term effects. What guys do to get their first ascent there. I've got my tick, you know. You've got to look 20, 30 years down the line, or, I mean, I've been climbing for 45 years, and I've seen, okay, boats in Europe aren't really that old, but certainly in 45 years I've seen a lot of things which we did then, we know now, are completely unsustainable. They're completely, you know, used to be good fun going trundling big rocks off the cliffs. And now we know that's not really the name of the game. You know, we're using it as a playground and not taking it seriously. The first standards for bolts actually appeared in 1908. We're well advanced in Europe. The Germans started bolting in 1905 in the Elbe sandstone, from which some of you may have heard. This is this area where they only use knotted slings for protection. You can leave all your cams at home. And because the rock is very soft, they started bolting. The first recorded one was 1905. And they used an existing military piece of equipment. You probably all know these Via Ferrata in the Dolomites and the Alps. They were built for military purposes to get the troops and guns and everything up on the top of the Alps, the mountains and the Dolomites, to fight the wars. Because especially in the First World War, there's a huge, it was the front line for 5 years, and they fought on the top of the mountains. You know, it's a bit weird there, because you climb up something that's sort of 5'8" or 5'10", you get up and then there's bunkers and all the stuff, because they actually fought up there, on the top, right on the top of the mountains, the high, 3,500 meters. And the military, to haul this equipment up the cliffs, had huge boats, because it was all done by manpower. And these boats were ideal for the sandstone, and they were the only sort of tested boat anybody had anyway. So these were used in this Elbe sandstone. And they are one of the reasons why the hardest climbs in the world at that time were from that area. They were climbing like 510B in about 1912. Because they were bolt protected. Because nobody had invented the carabiner. Right? So movable protection was really a bit dodgy. It didn't really exist because you didn't have a carabiner, so what could you do? So you just climbed up or fell off. But once they started making these bolts, they could actually go up and use the bolts. Of course, not having a carabiner makes it a bit difficult. So what you have to do is untie the rope, thread it through, and retie. And when you're doing 510s and stuff, it's not very easy. And it's vertical. It's just vertical standstill. But these bolts are really cool because they have a huge ring. It's a 4-inch diameter ring, and you put your arm through it. So you put your arm through, and then you've got two hands, untie the rope, then you tie it around the chest. You thread through and retied it and climbed on. And it's dead cool. And actually it's interesting because, the top climber at that time was an American guy who lived there. He was a racing driver. Mr. Harry Jones. This standard was, they used it till about 1928, and then the carabiner sort of took over. And so they reduced the size of the ring to more sort of meaningless. They're 2.5-inch diameter inside. Don't really know why they made it smaller, but they did. And even then, the standard called for a lifetime of a bolt for 50 years. They thought for the future, and they specified a 50-year lifetime. And they achieved it by the simple way of making them gigantic. there's just loads of metal in there to rust, because they hadn't even invented stainless steel those days. So the rings themselves, they have to hold 80 kilonewtons when they're new, so that, you know, the time and toll keeps them safe. There are bolts over 70 years old, which are still in use there. They're just about finished, but they gradually get changed. They're interesting though, because they didn't, of course, have any glue either. And so they're put in by the holes filled up with lead strips. It's quite a big hole. And this is where it's, you know, I read here all about this stance drilling and stuff, and guys standing there and there. Yeah, it's heroic. My brother says it's a heroic way of making a mundane task. You know, so, you know, we just get the drill out, you know, drill a hole. You guys stand there and bash away for an hour or two. But these guys, of course, there weren't any drills either. So they stood there, and you have to lead bolt. It's compulsory. You're not allowed to wrap bolt or anything. You've got to lead bolt. So you have to stand there and drill. But the holes are a foot deep, right? And they're 1.25 inches in diameter. So you take a hammer and forget all this D5 and all these, you know, wall hammers you guys use. It's a 5-pound lump hammer. And you stand there and you smash this hole, right? And it's a foot long. And then you fill it up with strips of lead. And then you have this bolt, and it's very slightly tapered. They're 6-sided, tapered, they're 1 inch across. And you put this thing in these lead strips, and you hammer it in. And if it doesn't take 60 blows to put it in, it's considered unacceptable, and you should take it out and place it. How you took it out, I don't know. And in those days, it was considered really good going to do 1 bolt in a day. Because you had to do it, there are minimum height standards for the bolts, and all they're too close together. And so you have to stand on your mate's shoulder to get high enough. And you stand on this guy, or sometimes 2 guys, or 3, you know, they just one on the other, and then hammer it away. And about sort of, you know, a few hours was sort of de rigueur. Sometimes they used to have to give up and come back the next day and finish the hole off and stuff. But they're pretty tough. They kept on. Then, of course, came the war, the Second War, that is, and the guys up there were cut off from the rest of the world, effectively, or the rest of the Western world anyway. So they carried on with their own standard, and the last issue of this standard is 1988, and they're still the same bolt. They have 2 standards then. They have a 22 and a 24 millimeter shaft, so 7/8 and 1 inch hexagonal shaft. And they also allowed shorter bolts for really hard rock. So shorter is like 8 inches, and the other ones were still a foot long. They kept going to 1988. That's the last revision. They really were advanced. You know, there's the metal specification is in it, the steel specification, everything is in the standard. Anyway, they became unified with the rest of Germany. And so there was the end of that sort of bolting system. You know, because they didn't still have any glue. You know, there's no chemical industry much over there. They still used the lead strips. So you still meet guys, you know, 40, 45 years old, who would put them in that way. I personally I've never installed one, and I never do have to. Because of this, the sort of climbing after the war became a bigger, more major sport. The 2 countries that really moved on with bolting, because the British didn't, were the French and the Germans. The French sort of embraced sport climbing very early, or invented it effectively. And they went to a standardized bolt. They had a long period of using really terrible, like cavers bolts, really horrible, like really short things, self-drilling bolts, and with 8mm studs or even 6mm, and aluminium hangers and all this sort of rubbish. And they were really pretty frightening. And they used to break a lot. So when this sort of sport climbing scene really came onto the scene, the sport climbers in France, they belonged to an organization called the FFME, They developed their own standard bolt. And these are, they're made of forged steel, hand-forged steel, and then galvanized, zinc plated. And they're made in an amazing old factory. It's like 300 years old, all by hand, and in the middle of France. It's a company that make equipment for farmers, you know, like gate hinges and all that sort of stuff. Anyway, this is the infamous FFME bolt. They're actually incredibly strong and very robust. But they have one really drastic problem which nobody thought about at the time. Predominantly the French are bolting in limestone, all that nice grey limestone. And it's only grey because there's a very fine lichen grows in the rock. And the galvanizing, or the zinc, leaches off the bolts and makes white streaks. It kills all the lichen. And so you get this big white streak under the bolt, about 3 feet long and 3-4 inches wide. And this looks awful, really horrific, you know. And so these sort of typical things that, you know, I know here you're very sensitive about painting the hangers and stuff, but there, you go to a cliff, it looks like a photo topo. You could see them for 10 miles away. You could see the roots. It's ridiculous, because, you know, there's a bolt every 2.5 meters, and underneath, well, 8 feet or so, and underneath there's a 4 foot long white streak. And then with a bit of wear from the carabiners, the zinc gets worn through, and then they start to rust a little bit. And so in this white streak, you've got a big red streak. And there's a few places, you know, Mont Saint-Victoire is very famous for this. You can see it from the other side of the valley, you can see what the roots are, you don't need a topo, you know, it's a bit of chalk from your hands is nothing. It's really horrific. These bolts were...
About 5 minutes.
Okay. So it's something to think about when you're, you know, bolting, is the impact. The British never got into this camouflaging bolts, or any other country in fact. It's only the Americans who seem to have bothered, because we do get criticism of, I was approached by some guys from a bird watching society, and they said, oh, but the bolts, you know, we said, you do know that birds are colourblind, don't you? The guy said, he said, you don't like the look of them. The birds don't care. They don't know what they are. You know, it's the bird watchers that don't like them. You know, the animals really don't care about them. But it's just something worth thinking about, you know, when you specify them. These galvanized bolts were they tried to put them into the European standard. This was actually the Americans, Helmut Mikroys, your delegate at that time. And he didn't like it, they were rejected completely. And the standard called for stainless steel. And the Germans, they had done the stainless steel thing. There's a guy called George Bühler. He developed the Bühler bolt, the glued-in stainless steel bolt, which actually became the standard European bolt. And has been accepted since then as more or less the best way to do it. The standard now has been changed, and now there is no material specification whatsoever. That's not to do with the climbers or what the bolts are or anything. That is actually a political decision from above in the standard system, because specifying a material is then a specification, not a standard. And the European Standards Organization is adamant that you don't specify things, you standardize them. You just say what it's got to do. And this is the other thing that you get in your situation. You do have to be careful, because these European standards are probably going to come to the United States, because they are going to be taken over by the ISO, the International Standards Organization. And so then they will be an international standard. So whether the Americans make their own standards, or they'll probably just look and take the ISO standard. And at least, almost certainly what would happen is an American manufacturer would be in a position to say, I will use the ISO standard. Because also it's compatible then with the European standard. And so there's a very good chance this is where your standards will come from. unless you actually make completely your own standard. But it's hard to see that you would really, an American standard would be much different from a European standard at the end of the day, because it's not really very detailed, the standard. It just says you make something that goes in this hole and it's got to be that strong. The only details are like rounding off the edges and the size of the eye in the hanger. But after that, it's really up to you what you make. You know, that's why there are so many different shapes and sizes. They all just fit. The material specification is free, but nobody makes, or nobody really uses anything but stainless steel in Europe. We are at the situation that was mentioned before. You can go to a Bile, a Stans, and you'll find 9 different bolts there, especially in Italy, where they used any old rubbish. And this is something that really is annoying people. You are running out of places to put bolts. And so what everyone's looking for now is longer life, much longer. So 50 or 100 years is the sort of what you should be looking at. We're now at the position we have a problem with the glue itself, to know because the glues aren't that old. They're supposed to have a lifetime of 50 years, but we don't know outdoors. We're not too sure whether this is actually so. All we know is the longest lived are cemented bolts. And I know it's not very trendy these days, but if you go ever climbing the Frankenjura, probably 50% of the bolts there are cemented in with quick setting cement, not glue. It's not very strong at the start, but it keeps getting stronger, whereas the glue goes the other way around. It's strong at the start, but they're organic, they deteriorate, whereas the cement isn't. The better glues, in fact, are the ones that use about 80% of the tuber glue is filler powder. It's not really resin, it's just filler. And nearly always the filler is actually cement powder. Just because of this reason. In the construction industry, they know that the polyester or whatever will deteriorate over time, but the cement powder will harden up. And this is why, it's cheap, but it's really horrible to use. You've got to mix this stuff, you know, and put it in the hole. It's not very convenient. Anyway, that's bolts. And that's the European standard. It's very confusing. It does take a long time to understand. It does mean that the bolters, it gives organizations leverage on the developers of routes. You know, if you get guys that are bolting with non-standardized bolts, you've got some sort of moral position. You can say, hey, you're producing shit. You're not helping the climbing community. In fact, in my home area, Germany, they rip your bolts out. If you don't use good bolts, they take them out. That's simple. They just change them. They're just gone. And you lose the first ascent. They take them out, and it's free for anybody else to do it and claim the first ascent, which is a good system. But the other side of the coin is they actually provide bolts as well. This is where, you know, politically it's a bit dodgy. But they actually provide bolts so that there's no excuse. The climbers can't say, oh, we couldn't afford it. They'd say, here are the bolts. Bolt it. And this is the way it's done. Okay, thank you very much.